As always, I start the project by printing all of my parts. This time I'm using black PLA as base and silver silk PLA as accent. There is also a single color version if you can't print multiple filaments. Silver filament is meant to simulate the aluminum ring similar to the Google Glass. Silver front gives a nice contrast to the black frame and also provides inside grooves for the wires. Here are the main side loader pieces. Those will be used to house the main components such as display and driver board. Those pieces are best printed in black since it blocks any light that might try to escape. This small piece right here is the display cover. It makes so that the display won't randomly fall out. The big piece is the side loader itself. It houses the driver board and acts as the hinge for display. And finally the display gasket. It houses the display and mounts onto the main side loader piece. After printing, make sure to remove any excess filaments such as brim and supports. If you leave those on your prints, you might risk bending the electronic parts, which will result in permanent damage. Here are the main electronic components. Unfortunately, those have to be bought on AliExpress. I have a custom driver board in the works, but it's not yet fully independent. Thankfully, all of the components come as a set. I've actually removed some of the wires from the plug because I didn't need them. Display comes with the 60mm ribbon. There is no more need to need the by 100mm one. I've redesigned the side loader so that it works with the original ribbon. I start the build by getting the display inside the plastic part. It's pretty straightforward. It requires some degree of precision, but it's not that difficult. The most important thing is not to bend the ribbon too much. With the display in place, you can now install the magnifying piece. Actually, let's put the display into the hinge first. It's super important to do it properly, as you can easily damage the ribbon at this step. Bending the top part of the hinge will make it easier to install the display gasket. It can be bent back after it's installed. You won't even notice that it was bent in the first place. You should now check if it moves properly. And now I will install the magnifier. With the magnifier and display in place, you can now put the small cover on top. Once again, this piece is important since it blocks the light from escaping. Now I will connect the display to the driver board. This time I've designed the plastic pieces so that you don't have to remove the connector. You can of course still do that to achieve the slimmest build. Ribbon cable is a bit short in this place, so it requires some precision to connect it. And now you just flip it back into the place. Connector should easily fit into the hole on back. You can connect the cable so you won't lose it. Also, driver board is really loose, so make sure that it won't fall out. Now I will install the side loader onto the headband. I'm using the custom electronics version, which works with my gyro core. There's also a version for the off-the-shelf components. The second version works with the regular Arduino Pro Micro. I don't have one at this moment, only this empty board. It's a small difference, but some people might like it more this way. The new Sideloader uses two self-tapping screws to connect with the headband. I'm using really small 1mm screws, those are about 6mm in length. I've left it slightly loose on purpose so that I can better position it on my headband. And now I can tighten both screws. It should now look like this, it's almost finished. If you have any difficulty with cable routing, you can remove one of the screws for more space. It will of course be installed back after routing. Wire tunnel is pretty small, but it should fit all three wires without issue. I'm removing one of the screws entirely, but the second one will be just made loose. And now you can insert the wires easily. Some wires can be too short, so I've left some space for the wire extensions. I will tighten both screws since wires are already inside. My wires are too short for this build since I've cut them many times before. To make this work, I will simply solder some other wires between the PCB and connector. The thicker wires you use, the better. But first, let's wire the gyro. For the gyro, I will need 4 wire pieces since it uses 4 Arduino pins. I will cut them slightly longer so that I will have some additional length to work with. With all the wires ready, I will now put them through the wire tunnel in my headband. It doesn't look super pretty, but it makes things way easier to have the wires slightly longer. I've made a test version of the assembly here, so you can see more or less how it looks. I will have to remove those boards from the yellow plastic and put them inside my headband. I will cut the wires for now, since I will have to redo them. I've removed the old wires and I'm now ready to install the board inside the headband. I will start by soldering the gyro board. I put some flags on the pins for easier soldering. This will eliminate any soldering errors. I've put some solder in advance, so I won't have to juggle the wires and solder at once. It's pretty easy to solder those wires, so everyone should be able to do this. After all the wires are soldered, pull the wires from the other end to put the gyro in place. Make sure that the solder pads are facing down. Gyro should get stuck on the wires, that is how I made it. This makes it so that the board stays in place no matter what. As you can see, there is a lot of spare wire length left. I will put the gyro core board inside first and then I will cut the wires down to size. Gyro core board should sit comfortably inside the plastic part, it shouldn't be too loose or too tight. Before cutting the wires super short for soldering, you have to check which wires go where. I will use my SMD measuring tool for that. You can use any kind of multimeter which has this kind of option. Here's my tester. It's a unit SMD tester. It has tweezers on its end, which is super useful for measuring SMD. The mode which we are looking for is marked by this small sound wave symbol. In this mode, tester will beep once both tweezer ends will touch. This will help check which wire goes where. I've attached one end of the wire to one part of the tweezers and now I will touch each solder point with other part. If it beeps, then I know which wire goes to that point. After wire is identified, I can safely solder it to the other board. All 4 wires are now soldered between both boards. The boards are now ready and software can be uploaded. Now I will install the HDMI board. This is a custom board designed by me. You can buy one on my Etsy or you can make one yourself. Of course, you can also use regular off-the-shelf HDMI converter. As I mentioned before, my wires are too short to reach the HDMI converter, so I add some in between. I will use some scrap plastic piece which I will melt into small PCB holder pieces. This will prevent the board from falling out. This time I will use slightly thicker wires for the connector. This will prevent the board from heating up. I will connect the wires to those pins right here first. You can do it in any order though. I've got all 3 wires soldered up, so I can now connect all the wires together. I could make the wires a bit shorter to avoid using all of the empty space, but it will do. Make sure that you connect the wires to the proper signals, otherwise you will burn something. As you can see, it's a bit messy, but all of the wires are now connected. The only thing to do now is to isolate them with some tape. I would advise on using shrink tubes if you have some. You should use proper isolation tape, but that's pretty much the best I could find laying around. Remember that you have to isolate each wire separately, nothing can touch. Here you can see my SAT wire bundle. I will just tack it inside headband. Now that wires are extended, I will tack on the connector to make it reach PCB. Make sure to be gentle, it's super easy to rip the solder pads. And just like that, HDMI portion of the glasses is now finished. You can see that it already shows up my Windows desktop. Don't mind the green squares, those won't be there when you make it. Make sure that display is set up as vertical and on the right side from main display. The resolution should be like this. In the meantime, I've designed some plastic covers for the electronic parts. Those are optional and you don't need to use them. Covers right now are installed by melting both pieces together using soldering iron. Classic Manolo maneuver. It may not look perfect, but it holds really well. I've also made covers for the gyro and gyro core. Gyro core cover has this small hole on the corner for the headband. It looks slightly better this way. I've also made this cover for the driver board, but I'm not super happy with it. And now the Sideloader is complete. It still needs the combiner, but I'll add it later. Now comes the software part. Download the Arduino software if you don't have it yet. And now install it. You will also need the chip drivers, just Google them. Driver installation is super easy, just run the executable. Now you can start the Arduino software. Install the Arduino drivers if you receive this prompt. Now you will need the FastEMU library. Just look it up in Library Manager. FastEmu library is made by Liquid CGS, the guy who made whole software which I'm using. You can find the original Hades VR software in the examples menu under FastEmu. I've also forked Hades VR GitHub page, you can find the latest Sideloader stuff there. The Arduino code can be found on my page, but you can use the original Hades VR file if you know how to modify it. Now you can open the ENO file and plug in the glasses. Glasses should now show up in the board manager. Check if you have the same values as me and click upload. Uploading will take about 10 seconds. Now open the serial monitor for gyro calibration. Now follow the instruction on screen. After a while you should see that it's now calibrated. Now find your SteamVR folder and copy the driver there. Make sure you're copying the driver and not the Arduino files. You can now connect the HDMI cable and start SteamVR. You should now see that it's working and waiting for the tracking calibration. Click on the standing only option. Now put here your actual height while you stand, don't put 0 or something ridiculous. I'm a man that's 170. Your glasses are now ready to use. Your glasses are not in fact ready to use, since we have to install the combiner. I'm using the car HUD plastic for this piece, you can find the link on my Discord. I've made this yellow piece to help me mark the correct shape for the combiner. I will push it down onto the plate and mark the shape with knife. Now you can use the Dremel tool to cut it to correct shape. It's now ready to use, just peel off the protective film. Combiner mount is slightly loose since HUD plastic thickness varies slightly from seller to seller. I will fix this by melting the combiner and plastic piece together. Now the Sideloader is truly ready for use.